Hi guys, in this video I'm going to walk you through how to calculate the pH of a base using pOH. Alright, so two new formulas we're going to add in. The pOH, or power of hydroxide ions, is going to be equal to negative the log of the concentration of hydroxide ions. Now, we're used to thinking of things in terms of pH. So a lot of times we're going to take this pOH that we find and convert it. So another useful formula is going to be pH plus pOH equals 14. You want to have these two formulas memorized, ready to go. So for example, if something has a pH of 2, right, I could plug that in, 2 plus pOH equals 14. That means that the pOH of that same solution would be 12. All right, let me show you where this could be useful. So what if, right, your problem says calculate the pH of a 0.0010 molar sodium hydroxide solution. All right, now pH is the power of hydrogen, but here we know that sodium hydroxide is not really going to dissociate into hydrogen ions. It's going to dissociate into sodium and hydroxide ions. Since it's only going to dissociate into one hydroxide ion, this concentration can stay the same, so we can plug it into our pOH equation. So pOH equals negative the log of the hydroxide ion concentration. Pulling that from this formula up here. 0.0010 molar. Okay, plug that in to your calculator. Negative the log of 0.001, and you should get 3 as your answer. So the pOH for this solution is 3, which means it's a pretty strong base. But again, I'm going to convert that to pH because that's how we're used to thinking of things. So remember, pH plus pOH equals 14. I know it has a pOH of 3. So pH plus 3 equals 14, right? Subtract 3 from both sides. The pH of this solution is going to be equal to 11, which again is a pretty strong base, sodium hydroxide here. Okay, let's look at another one. Maybe it asks, number 5, what is the pH of a 0.020 molar strontium hydroxide solution? Okay, now here we have to pay attention because when this dissociates, I'm going to get 1 strontium ion and I'm going to get 2 hydroxide ions. So I'm not going to have 0.02 molar when it comes to the concentration of these hydroxide ions. I'm actually going to have double that. So I need to go ahead and double this. So I have 0.04 molar hydroxide ions, and that's what I'll plug into my pOH equation. So pOH equals negative the log of hydroxide ion concentrations, which here is 0.04 molar. Plug that into your calculator or the internet. I, for example, am literally typing in negative the log of 0.04 into the Google search bar because I do not have my calculator on me. And for my answer, I get that pOH equals 1.40. We'll round it there. All right, but that's not the question asked. The question asked for pH. So I've got to do this extra step here since this is a base. So pH plus pOH equals 14. pH plus 1.40, that's what I found the pOH to be, equals 14. Subtract 1.4 from both sides. So the pH here is going to be equal to 12.60. A strong base. stronger than my base up here. Okay. So that's how you would calculate the pH of a base using pOH. I'm going to make one more video with some different questions that I should ask you, but we're almost there, guys.